After-topic tutorial. How does generative AI work? Generative AI represents a significant leap in artificial intelligence, where the focus shifts from predictive analytics to the creation of new, original content that can include text, images, sounds, and more. At the heart of generative AI are neural networks, which are complex algorithms modeled after the human brain's neural architecture. These networks are capable of learning patterns and structures within vast amounts of data through a process called training. During training, the neural network is fed large data sets and uses statistical methods to learn the underlying patterns and features of this data. Once trained, a generative AI model can produce new content that mirrors the learned data. This is achieved through various methods, such as unsupervised learning, where the model identifies and learns from patterns in the data without being given explicit instructions. Semi-supervised learning is also used, where the model learns from a combination of labeled and unlabeled data, providing a balance that can lead to more accurate and diverse content generation. One of the key components of generative AI is the ability to evaluate the quality, diversity, and speed of the generated content. Quality is crucial, especially for applications that interact directly with users, such as chatbots or image generation tools. The content must be coherent, contextually appropriate, and, in the case of images, visually indistinguishable from natural images. Diversity ensures that the model captures a wide range of possibilities within the data distribution, reducing biases and increasing the applicability of the AI. Speed is essential for interactive applications, where users expect real-time responses and outputs. Developing generative AI models involves various types of neural networks, each with its strengths. Diffusion models, for instance, use a two-step process of adding noise to the data and then learning to reverse this process to generate new content. This method allows for the creation of high-quality outputs and is particularly effective for complex data types like images or audio. Another type of generative model is the variational autoencoder, VAE, which learns to compress data into a lower dimensional space and then reconstruct it, allowing for the generation of new data points that are similar to the original dataset. Generative adversarial networks, GANs, involve two neural networks competing against each other. One generates content while the other evaluates it, leading to a continuous improvement in the quality of the generated content. Transformers, a newer class of models, have also been instrumental in advancing generative AI. These models are particularly adept at handling sequences of data, such as text or time series data, making them ideal for language-related tasks. For example, GPT-3, a transformer-based model, has demonstrated remarkable capabilities in generating human-like text based on prompts, enabling applications like ChatGPT. The development of generative AI is not without challenges. Ensuring that the generated content is not only high quality, but also ethical and free from biases is an ongoing concern. Additionally, the computational resources required for training and running these models are substantial, necessitating continued innovation in hardware and optimization techniques. In conclusion, generative AI works by leveraging complex neural networks to learn from data and generate new, original content. The technology is rapidly evolving, with diverse applications across various industries. As generative AI continues to mature, it holds the promise of revolutionizing how we create and interact with digital content. After-topic tutorial: how can I create my own generative AI model? Creating your own generative AI model involves several steps, starting with choosing the right framework. Popular frameworks like TensorFlow, PyTorch, Keras, and Fast.ai offer robust tools and libraries for AI development. For instance, TensorFlow is an open-source platform known for its flexibility and comprehensive ecosystem, while PyTorch is favored for its dynamic computation graph and user-friendly interface. The next step is data collection and pre-processing. You'll need a large and diverse data set that's relevant to the type of content you want to generate. This could be text, images, or audio files. The quality of your training data is crucial, as it will determine the quality of the AI's output. Pre-processing may include cleaning the data, normalizing features, and converting it into a format suitable for training your model. Once you have your data ready, you'll define the architecture of your generative model. This includes setting up the layers of the neural network and selecting the appropriate algorithms. For text generation, you might use recurrent neural networks, RNNs, or long short-term memory networks, LSTMs. For image generation, convolutional neural networks, CNNs, are commonly used, and for audio, WaveNet-like architectures might be appropriate. After defining your model, you'll move on to training it with your dataset. This involves feeding the data into the model and adjusting the model's parameters based on its performance. Training a generative AI model requires significant computational resources, so access to powerful hardware or cloud computing services can be beneficial. Once the model is trained, you'll evaluate its performance and refine it as needed. This might involve fine-tuning the model's parameters, retraining it with more data, or adjusting its architecture. Tools like Hugging Face transformers provide pre-trained models that you can fine-tune on your dataset, which can save time and resources. Finally, you'll deploy your model. This could mean integrating it into an application or making it available as a service. Deployment platforms like Google AI Platform or Vertex AI can simplify this process by providing the infrastructure and tools needed to host and manage your AI model. For those who are new to AI development, there are resources available that offer step-by-step guidance on building generative AI applications. Microsoft's Generative AI for Beginners course is an example of a comprehensive learning resource that covers the fundamentals of generative AI and provides practical coding examples. In summary, creating a generative AI model is a complex but rewarding process that involves selecting the right tools, preparing data, defining and training the model, and deploying it for use. With the right resources and dedication, anyone can embark on this exciting journey into the world of generative AI. For detailed instructions and best practices, the guides provided by experts in the field are invaluable resources that can help you navigate the process.